Hi, in this video I'm going to show you how to deploy a Micronaut function to AWS Lambda, position it in front of an Amazon API Gateway HTTP, generate the infrastructure with Amazon CDK, which will enable us to create infrastructure as code. And we will also create the Lambda with AWS Lambda Snapstart enabled automatically. So I'm going to generate a new Micronaut application and using the latest Micronaut version release, which at the time of the recording is Micronaut 3.9.0. I'm going to use actually here I have also the Micronaut CLI in the console. So I'm gonna use a CLI tool that we added in recent versions of Micronaut. So I'm gonna do mn create AWS Lambda, and this is essentially a guided through wizard which will simplify the creation of a Micronaut function to be deployed to AWS Lambda. So the first question is, how do you want to write your application with controllers or functional style with a handler? So I'm going to write my application as I am used to with controllers, because this Lambda is going to be invoked with an HTTP trigger. So I'm going to click number 1. Then choose your trigger. So it says the default is Amazon API Gateway REST API. I'm going to select number 2, Amazon API Gateway HTTP. Then it's telling me how do you want to deploy it, fat jar running in the managed Java runtime or a native executable built with Gradle VM. In this video, I'm going to go with a fat jar, so I'm going to select 1. Then my architecture, I'm going to go with x86 because that's the only architecture supported by AWS Lambda Snapstart at the time of this recording. Then it asks me, do you want to generate infrastructure as code with CDK? I'm going to say yes. And I'm going to go with the defaults. I'm going to go with Java, JUnit for test framework, and Gradle as the build tool. I'm going to select 11 as my target JDK. And I'm not going to add any extra features, but I could. So I'm going to click name of the project, and I'm going to say demo snap start. And I have an application created in this folder. I'm going to open this application with IntelliJ. I'm going to show you in a second. I'm going to say yes, please trust project. Because we selected the CDK feature, so what we did in the wizard is the equivalent as coming here and do AWS Lambda CDK and Amazon API Gateway. So essentially it's the same thing that we did with the command line interface. We can do directly in the website. I can select these 3 features, and because I want to write my application with controllers, I select the default application type. And here AWS Lambda Snapstart currently doesn't support JDK 17, hopefully it supports soon. So I will select 11, and the defaults were Java, Gradle, and JUnit, which is what I selected in the command line tool. So that will be the equivalent. I have here a multi-project build generated by Micronaut. So let me make it actually, let me go to presentation mode. So I'll show it to you. So I have here a multi-project build. I have an application and an infrastructure module. The infrastructure module will create Amazon CDK stack, and inside the stack it will create a function. Micronaut has a module which enhances a little bit CDK to create Micronaut functions. So we have a class with a similar builder interface that Amazon CDK offers for Java developers. So I'm saying here this is not using Gradle VM, and I have here some environment variables specifically targeted for Lambda. You can I am disabled here X-ray because AWS Snapstart currently doesn't support X-ray. The target architecture, and here is where things start interesting. So here I am enabling AWS Lambda Snapstart. I am gonna publish a version of my function because Snapstart works on published versions, and then I'm gonna create an alias to that version, and I'm gonna set up an API gateway which is gonna point to that alias essentially. You see here where I pass the alias here. Amazon API Gateway HTTP supports 2 payload version 2 and version 1. Micronaut AWS Lambda currently only support version 1. So that's why I selected here version 1. And that's all I have. Then in my application, I have one controller, nothing fancy, as you can expect. It's a hello world controller. Micronaut controllers will respond JSON by default, so this is going to render this map as a JSON object, so it's going to have a key of message and a value of hello world. And that's all I have. We actually generate a useful bash script, which is everything that you need to deploy your application. So I'm gonna generate a fat jar of the application, then I'm gonna run the test, and then I'm gonna go into the infrastructure folder, I'm gonna synthesize, and I'm gonna deploy actually with requiring approval. So in production, you probably want to require approval. And here we are actually testing what we deployed to see that the thing that we deploy automatically responds hello world. So if I go here to my AWS console, so this will by default, it will use the to execute this CDK CLI commands, it will use my default AWS profile, which is pointing to this account that I'm going to show you in a moment. So I'm going to go here to my AWS account. I don't have any function deployed. If I go to CloudFormation, I have run CloudFormation in this AWS account before, so that's why I have this CDK toolkit. So I'm going to run this test Lambda script, and this is going to generate the fat jar. As I was saying, it's gonna generate my infrastructure as code, and it's gonna deploy my application. Okay, the script finished. You see success here at the bottom. That's why we sent a curl request towards this URL, and we return hello world, so I can actually show it to you. So if I come here, select the URL, which is the output, is basically the API, Amazon API Gateway HTTP URL. If I do a curl command, I will see a hello world here. I'm gonna go to the AWS console. I have now a CloudFormation stack. And if I go to the Lambda console, I will see one function. Actually, we'll see two. One for CDK, the one with the runtime node, and the other one for the actual where we deployed our Micronaut function, which is using the Java 11 runtime. I click in the function, and we're going to see that this is connected to, and actually, let me show you. If I go to API Gateway, we will have an API Gateway for this function, which is an HTTP API gateway. We have routes, and we have like a proxy route, which is essentially proxying everything to the Lambda function. You see the Lambda function that we just created. So we are using the proxy capabilities of Amazon API Gateway to proxy all the requests, which reach the API Gateway and forward them to the Lambda function. The Lambda function was written with controllers, as you will write a Micronaut application with different runtimes, such as Netty or Servlet runtimes. So your programming paradigm is the same. If I go to monitor, I can go and click in view cloud.logs, and I will be able to see the request time. So I executed this twice, so we'll probably see like a cold startup here with 4 milliseconds and a warm invocation of 4 milliseconds or 5 milliseconds, and a cold startup which took the restoration took 157 milliseconds, and the duration 200 milliseconds, so below half a second. Called startup for a Micronaut function deployed to AWS Lambda with a Snapstart enable. Let me show you a Snapstart enable in the AWS Lambda console. So if I go to our function and I go to configuration, you will see that I have here a publish snapshot, a Snapstart enable for published versions. If you created this function manually, you can always change that here in this dropdown. And another thing that we defined in our CDK code was an alias. So you can see here the alias that we defined, which is sending 100% of the traffic to the version 1 of our application, which was published. and this is a version that has Snapstart optimization turned on. So that's all I wanted to show you in this video. As you can see, it's really easy to get started with AWS Lambda, AWS Lambda Snapstart, Amazon API Gateway, CloudFormation to define your infrastructure as code. I think we have a great combination of features in Micronaut to make Java a joy in the AWS Lambda service. Hopefully you agree with me, so check it out and let me know what you think, and hopefully we see you soon. Ciao.